This is Andrew, and this is going to be a lesson on Introduction to TDD. We're going to use VB.NET and Xunit, but first we're going to talk about why TDD. This way, when you write your code, you'll have tests first that help you design the API. You'll have a clear reason to be writing your code, and you'll have no excuse at the end for why you didn't write your tests because you already have them before your code. Then we'll also show the red-green refactor pattern here. So let's switch over to Visual Studio. And on this project, this is just a brand new console app for VB.NET. And the first thing we have to do is add our test project. So we're just going to add a new project in the same folder. I'm just going to use a standard MS test unit test project. We're going to call it tic-tac-toe tests. And wait a second here. So we're going to take this and we're going to call this game board tests. And we want to use Xunit, not Microsoft Visual Tests. So we're going to remove this here and we're going to add a NuGet package. Sorry. So we're going to manage NuGet packages. We're going to browse. We're going to find Xunit. So I'm just going to install this here. I'm going to take the defaults. It's going to add some stuff for me. And then I'm going to go through and start cleaning this up. So MS tests makes you do test classes. Xunit doesn't care. And then test methods in Xunits are actually called a fact. So we need our first test here. And probably the easiest test that we can start off with is an empty board. So we're going to, I guess, first import Xunit so it doesn't scream at us this whole time. And we're going to say we're going to have a test where the empty board returns false. So it's going to be a fact that the empty board is going to return false. And the way we're going to do this is we're going to use a board and it's going to be a multi-dimension array that is a string. So we're going to do new string. I'm going to copy and paste my tests later so that you guys don't have to suffer through me typing. But for now, we'll just do this one. And then the board's going to look something like this. So that should be nice and happy now. So then we're going to do dim, and then we're going to do system under test here. And we're going to do a new class that we don't have called board checker. Or let's keep in line with our test name, and we're going to do game board. And then we're going to dim the result and set that equal to the system under test dot checkboard. All right, so that's not going to find anything. It's going to be really sad. That's okay for right now. And then we're going to assert that the result's going to equal false. So the next unit, it looks like this. So we have our first test, and if we build here, we're going to have a failing test because it's not going to compile. But that's not really the point. I'm not saying you should have non-compiling code before you move on, but what we'll do here is we'll add a new class, and it's going to be called GameBoard. And we're going to grab our function name here, checkboard. Give me 1 second here. So then we're going to write a public function checkboard. and it's going to take in a board as a string multi-dimensional array, and it's going to return a Boolean. And right now, if we, just to make it compile, prove we have a failing test. Sorry, we have a game board is not defined. Okay. So we have to add a reference to tic-tac-toe. We'll rerun the test here. Oh, we forgot to pass our board. All right, so I found our test. It didn't run our test yet. Sorry. Oh, this is the first thing I wanted to show you. So I ran it a couple times. I couldn't figure out why it wasn't going. But the problem here is that I pulled in the default NuGet packages with Xunit. I didn't actually pull in all the packages I needed. So with Xunit, it pulls in all these analyzers and stuff, but it doesn't actually pull in the Xunit runner for Visual Studio. Right here, you can see there's a red X, or an X. It didn't install it. So I need to install this one really quick. And then once I have that XUnit runner Visual Studio, it'll actually find my test and actually run it this time rather than expecting it to be ran at the console. So here's my failing test now. The empty board is supposed to return false, but it returns true. Easy enough. We can fix it. When you do TDD or when you're just trying to make the test pass, you just do the least amount of code to make it work. We obviously know we're going to have more rules to implement for tic-tac-toe, but this is the bare minimum that we're going to need. So the next test we're going to do is, I think we're going to do something like testing diagonals. So if we do, sorry, I'm in the wrong thing here. So if we do, I'm going to put it at the top here. We're going to do another fact. And we're going to do public. These need, your tests will need to be public. If you do them private, Xunit won't find it. Check diagonal. I'm trying to spell this right, so I think that's right. If it's not, you can yell at me. So check diagonal, and what we're going to need here is a test that looks almost like this. This is going to return true, and we're just going to do something like that. And we want a second test while we're here. And just because I can't think of a better name, we're going to do, sorry, there. And we're going to switch this to be O's here. So I've written this ahead of time, so I'm not going to make you watch me type this. Just give me 1 second here. But I will explain the code that I wrote. So we're going to paste this in here. So we have an upper left on the board. We have a center. We have a bottom right. We have an upper right, and we have a bottom left. And we're gonna comment out this line for a second. So normally you're gonna only do one case at a time, make it pass, then do the rest of it. So let's just do this here. So if we run these tests now, we added the code to make one of our diagonals work, but we blew up our empty test board. To fix that, we can add this code here that says if the center's not equal to null, then we're going to be okay. And then we can add our other diagonal back in. So we got that working, but then we're going to need our next test case. So the next test case we're going to do is going to be a little bit different. We're going to do what's known as a theory in Xunit. So we're probably going to check the rows next, I think. So if we come back to the game board, that our unit test here, we're going to use something new in Xunit called a theory. And what that's going to do is, let me finish the formatting here. A theory lets us have a fact, but instead of being empty with no parameters, this one's going to take test data. Normally how these work is they would take inline data. So that would look like this, inline data. And that would be like this. And you can see it's a parameter array of objects, but it won't actually so if I did something like this, it would let it work. Um, just fill it in with something. So this would actually take this as a string and this is a Boolean. So it's telling me it won't actually match. But it won't actually take an object like this that we have to initiate for our board. So I'm just going to remove that inline data and go back to my member data. Actually, it allows you to use functions like this. It also allows you to use like class data, so you can refer to another class to get your data that you need. It's really powerful because this function could read from like a text file. It could read JSON. It could do anything to return this data to you. However, it does that or generates that, and then it runs the tests over that. So it'll create 6 tests, one for each line of data in here. So we're going to be checking rows, and we have X's, we have O's in the middle, and we have X's on the bottom, and then that's going to return true. That's going to be our expected result. And then we have ones that don't make full rows, and we want those to return false. So that looks like this. We're just going to have our board be passed in, our expected passed in. We're going to have a game board. It's our system under test, going to run our same function, and then we're going to run the same expected result. If we run this test here, we're going to get some passes because we've got these failed tests that are still going to fail. But then we've got our 3 red ones that we want it to be true. And when you look here, if you actually look at the Xunit output, you can see what the expected data that came in was for each of these tests. And if there's any other comments here, you can kind of see which test would fail. So if we had a smaller test set, you could see all the parameters here. So if we go back to the game board, I'm going to put the code up here above the diagonal stuff we did. I'm going to do check rows. And I'm going to comment this down here just so we remember, check that. We'll just leave it there. And let me grab the code I wrote before for this. So the goal here is write the least amount of code we can and just pass these checking rows. So we're going to loop through 0 to 2, and we're going to check, and hopefully this logic makes sense on TD arrays of what we're doing here. But as long as everything matches in the row, we're going to check the first position, the second position, and the third position. And as long as they're not blank, we're going to return true. So we're going to run this test here. And it returned all passed. So then we're going to do the next test, which is going to be columns. And for time, I'm just going to dump that back in here. It's almost the exact same thing as what we did above. We've got a new group of data here called column test data. We're going to have a theory that reads that test data. And this is the only difference is here we have the columns that would pass true and false. So if we rebuild these tests, if we rerun these tests right here, we're going to have some new tests pop up for check column. We're going to have 6 new tests, and 3 of them are already passing. So if we just go back to the game board here and we modify this, we're going to get something that looks like this. And we're going to do check column. And I'm just going to flip all of these. Sorry, and that should be 1I. Take just one more second here. And we got to flip this one. But that should give us now passing tests here. So if we flip back to our Y slide that we had earlier, we can see that we had red-green refactor pattern that we wanted to do. So here now we have all these tests that we have. We have some logic on the board, but this is starting to look more like a monolith. So what we can do is we can refactor these out, and I'm hoping it looks like we can try to refactor this out. I'm not sure if this actually works as well, and it doesn't seem like it works in VB. But what we're going to do here then is create a private function check rows, and it's going to take a board as string as boolean, and we're going to drop our code in here. If it doesn't find that it's true, we're going to return false. So this is all happy. It's not being called yet though. So we're going to come up here. Instead, we're going to do this, and we're going to say if check rows, then return true. We're going to make sure we put our board in there. And then we're going to rerun our tests, make sure we didn't break anything there, and we still have everything passing. So we're free to refactor now. We can remove things like comments that don't make any sense. We can do nearly the same thing here. Check columns and grab our logic from right here, dump it right there, save it, and just make another check like that. And then return true. Again, we're going to be able to run our test really quick. Oh, we broke something. We didn't compile there, but we're going to rerun the test. So our checkboards passed all that, and we can also pull out this as well, do the same thing. So we can have these, but the advantage here is you can see that we're still, even though we have these other functions here, we don't actually have to write new tests to test these functions. We've already tested those by writing our code and tests here first. Then when we refactor, all of this code is still covered for code coverage reasons, or all this code is covered by tests. So when you refactor, there's no reason to write tests specifically for this check columns. I don't have to call it specifically because it's called by this one. It's just one of the nice things about writing your test first is then you don't have to go back and check this after checking this. You know that your logic is covered by testing the public functions, not the private functions. So that's really all I wanted to show here. I don't think there's anything else to show. I mean, I could pull out this diagonal one. But I'm going to switch it to my last slide here. And so, you know, well, I have a typo here, but make it work, make it right, make it fast. Um, there's when you do these tests, make your tests work. Go ahead and refactor, make it right, and then at that point, if you need to do speed optimizations, you can make it fast. And but at least at that point, even if you make optimizations, you should know that your tests all pass. So hopefully this helps. Hopefully this is a different look at TDD that you haven't seen before. And I guess shoot me any comments if you like this video. Thank you.